Bismillahirrahmanirrahim. Assalamu alaikum, dear students. This is our second problem of fluid mechanics. Okay. So let us first come towards the statement. What is the approximate mass of air in a living room? 5.6 meter into 3.8 meter into 2.8 meter. Okay, we may say that one is length, one is width, one is height. Okay, what is the approximate mass of air in a living room? 5.6 meter into 3.8 meter into 2.8 meter. So here definitely, dear students, because this is, we are going to determine mass of air. Air is a fluid. Air is treated as included in gases. Okay, so definitely this problem relates to fluids or fluid mechanics. Okay, so now we come towards its solution. Okay, density is mass per unit volume. What is this? This is definition of density. Okay, density is mass per unit volume. Now we are going to give mathematical expression for density. Okay, if a mass m of homogeneous material has a volume capital V, then its density denoted by rho. Okay, density symbol is called rho. This rho is to some extent similar to P, but it is not P. This is called rho. Okay, density is mass per unit volume. If a mass m of homogeneous material has volume capital V, then its density rho is given by rho is equal to m over capital V. Okay, that is density rho equal to mass over volume. We have designated this expression as equation number 1. Okay, we know from table of densities that density of air is 1.29 kilogram per meter cube. Okay, dear students, actually that table is here. This is that table. Densities of some common substances at standard temperature 0 degree centigrade and pressure atmospheric. Okay, in this list at the top air is given. Okay, air 1.29 kilogram per meter cube. Okay, then air at 20 degree centigrade, its value is different. Okay, we will take this first value 1.29. Okay, then there is aluminium, benzene, brass, copper, etc. so and so. Okay, we are concerned with the first value. Okay, we know from table of densities that density of air is 1.29 kilogram per meter cube. Okay, rearranging equation number 1 as m equal to rho into V. Okay, when we keep m on one side, then definitely this volume V will be multiplied with rho. So m will become equal to rho into V, and using volume equal to length into width into height, we get m equal to rho into V equal to 1.29 kilogram per meter cube into 5.6 meter into 3.8 meter into 2.8 meter. Okay, when we, because dear students, we are given these three values. Okay, 5.6 meter into 3.8 meter into 2.8 meter. So we have used these three values, and hence this meter cube will be cancelled out with this meter cube. Okay, because 5.6 meter into 3.8 meter into 2.8 meter, this meter cube will be cancelled with this meter cube, and we will get answer in kilogram. Mass will become equal to 76.86 kilogram. This is the solution of our problem. Now we are giving a reference book. Okay, from where we have chosen this problem. Our reference book is Physics for Scientists and Engineers with Modern Physics. Its author is Douglas C. Giancoli. Its publisher is Pearson, and its fourth edition 2009 has been followed. While chapter under consideration is chapter number 13 under title Fluids. Okay, and this problem is enumerated as second problem of this chapter, that is exercise number 13.2. that is second problem of chapter number 13, and this is the end of our module. Okay.